All right. So on this, so we're talking about building up context, a context file in Revit, and there's a couple of different ways we could go about this. If this were a larger project, if we were covering something closer to half mile to mile range, I would probably be doing this in format, right? But we're really not in this case. In this case, we really need a high level of detail because this is a small-ish project in a dense urban context. I don't know that I call our campus dense, but we need to be able to see differences in things like sidewalk to grass, not just painted on, but actually modeled in place. We need those differences. At a university campus, so when we get at this kind of scale, so this is the quad and the handful of buildings around it, and maybe this should expand into this area right here. That file in particular is very much immersive, right? We're getting really down and into this. So if this was a larger thing, right, format, but we're getting pretty detailed. We're going to keep the buildings very much massing, but we really need to have that level of detail where it's really clear and easy to see sidewalks, something that's easy for you to start manipulating as you design the flag plaza, as you get into this final project. Okay, so this is set up the way that it is. This is sort of put together like a puzzle piece. Okay. Let me close this so it's not ringing the whole time. The point is, in terms of how this is working, there isn't anything that's on top of anything else. Okay, so if I select this as my family, so I'm just going to go edit and place, what you're going to see is each one of these is put together as its own piece, drawn really quickly. Right? Accurate-ish, as accurate as the JPEG file that I brought in underneath, that I'll show in just a second. But there's nothing that is on top of anything else. That is, there's nothing stacked. I didn't do a large square, like I didn't do this square as one piece, and then build this on top, and then the sidewalks on top of that. And the reason why, you've all seen what happens when you have coplanar geometry. Two pieces of geometry, same place, same time. You get this weird flickering thing that happens, right? Even if there's something, once you get into a larger scale like this, 6 inches apart often isn't enough on a larger urban context model. 6 inches apart, if it's a quarter of a mile away, relative to the computer, it's going to think that those things are on top of each other, and there's the potential of getting that flickering. So each piece is its own little unit. Okay, so if I go edit and place and I look at the sidewalks are right here, edit extrusion. They're sort of done in pieces like that. And what happened with those is you can see there's a larger piece right here that I went and voided out those pieces on the inside. I could have done the same thing without voids and sort of drawn this sort of larger shape and then drawn all those shapes and not done a void, right? Just left them as openings on the inside. But the advantage of doing voids is I only needed to do sort of smaller groups at a time. And doing smaller groups at a time just keeps things a little bit neater. Again, when you're working in custom creation objects, anything that's off in Revit, any overlapping lines, two lines on top of each other, two lines that aren't trimmed together perfectly, that's going to give you an error. So the idea of doing hundreds of lines all in one pass, the potential of having one error that you have to dig in and find someplace is really annoying. So I always try and keep those as smaller groups, so I'm never going back more than 4 or 5 minutes to find a mistake. If I have to go back into 30 minutes worth of drawing lines to find one line that's not trimmed together correctly, it gets really, really annoying. So I'm always trying to compartmentalize these pieces to keep it workable. Okay, so that's the basics of how that file came together. Okay, so the next thing that we need to look at is if we go to Site, you'll see the parts that have been modeled. I'm going to take this view and switch it to wireframe so you can see underneath everything. So again, wireframe gives us that X-ray vision on it. We need to go ahead and place a handful of these buildings in and get them modeled. And again, I'm going to leave it up to you how much detail you put into these individual buildings. I'm just going to basically box them out and keep it really, really simple, okay? But we need to be able to dig up and find heights on several of these as well, okay? So let's work through doing that really quick. So the best way to get heights on buildings is going to be Google Earth. Well, I shouldn't say the best way. The best way is to hire a surveyor to go out and shoot points and give you exact heights on buildings, right? It's even better than having the original working plans for a project. But unless all of you want to pool together $1,000 a piece or something like that, we're not going to hire a surveyor. So when you're starting a project early on, or when you're doing a project academically, Google Earth is your friend, okay? Because one of the things Google Earth does is it gives you elevations above sea level on pretty much everything. Okay, so wow, where am I? That's exciting. I think that was like week 1 of the class, wasn't it? So let's go Drury, University. All right. Slowly coming in line. So we're going to start here just by looking at Bay. And we're going to work through just 1 or 2 of the buildings. Might only be one. We'll just see how fast we can get through them here. And then we will, essentially then I'm going to turn you loose. Okay? All right. So, it's been a while, Google Earth. If you look at, let's see here. Come on. Yeah, we're in meters. Wow. It has been a long time, Google Earth. I'm not even sure I remember exactly how to get this back to feet and inches. Hopefully it's right here. Feet and miles. So that was underneath our, right here underneath settings, if you need to change that. I mean, that tells you it's been a long time if I actually had to go back in and change that for myself. But I'm just simply going to look overhead at this. And if you know, so Revit, I did not build any of this with topography. Across our campus, we definitely have topography moving up and down. Is it relative to the Flag Plaza? Not really. I think we can assume, just in terms of building this graphics package, I think we can assume it flat, right? So keeping that kind of simple in terms of how this is going to come together. So to get the height of something like Bay Hall, there's the fire stack right here, the fireplace thing that happens in it right here, and then there's sort of 2 heights on the roof, and then there's the front entry. So if I hover over that, I've got 1313. If I hover over the roof here, I've got 1333. Somebody math that out for me. 1333 minus 1313. Thank you. So inside of Revit, we're going to come in and do architecture, component, Model in place, generic models, and OK. And this is an extrusion starting at 0, ending at 20. And I am simply going to trace out that portion of the roof that is at 20. Right, so I've got that as my purple lines, 0, 20. I hit that one. Okay, so from there, if I go back into Google Earth, I should, and there's a limitation to this for sure, but if I hover over that chimney element, I can get a pretty good idea. If something is too small, it might not always pick up the difference in height on it, but I'm 1339, so it is 6 feet taller. So we're going to do 26 for that. I'm going to keep that in the same family, by the way. Doing something like this, one building, one family, usually. That way, if I need to move them around, they're pretty easy to move around. So let's do create, extrusion. This time will be 26. So I've got that piece in. I haven't changed my material away from grass yet. Yeah, fix that here in just a second too. Now we need to do this lower roof and upper roof. It looks like I bungled that too. Let's fix that before I get any further here. It's going to come over and up and trim together. Okay. This lower roof, and you know, okay, there's there's a roof height here and here and here. I'm not going to get that far into it. So that is 1323. So that is 10 feet lower. So that's 10-foot roof height relative around that corner. So again, create, extrusion. Oops. Create, extrusion, oops. All right. So this piece traces out. And again, I'm looking for, the site context that's already been built. There are a lot of edges and things like that that are already in place to work with. It's not imperative that you work with those. There's nothing that's going to create like a gaping hole in the site in terms of how I've put that together. But it's definitely nice to use some of those things as guides as you work through this project. Now, where the different heights of the roofs are lining up, definitely you want to take time to match those things up pretty much perfectly. So like around that edge right there, you can see I was using the pick lines tool rather than draw lines. So that way I'm lining up those edges perfectly and getting all of that trimmed together. So all of that's going to be 10 feet. So essentially I have a series of these 3 roof heights. Although that one looks taller. Oh, yep, did that one wrong too. Let's do it this way. Uh-oh, Jenga. So I need to build this last one right here. That looked like it was definitely a different enough roof height. Although it looks like they have it wrong on theirs, because that looks all like the same height to me. So that is 1335. Oh, that's only a little bitty one. That's a 2-foot step up. We'll keep it exactly like it is. And there's then. So last one, create extrusion, 22 feet. And so I have that. Okay. If you're not quite through with that, it's totally fine. But I'm going to select all of those. You can see its material is greens, which was all the green spot because green things. And I'm going to create a new material for that. Create new material. And something like this, all of you are going to find your own sort of method of building this inside of Twin for your final visuals. But for something like this, I'm probably going to put all of the existing buildings as the same material. And just sort of make them a nice, warm, matte gray so that they fit nicely into the context and background. I want to keep the geometry simple. If this was a semester-long project, you might want to be thinking about building all those columns for Bay Hall, things like that. But for right now, and given that this is a 10-day project, keep them simple. Unless there's something really relevant, like if I'm going to take the columns from Bay Hall and extend those into becoming the Flag Plaza, right? I'm going to respond directly to that context. I would keep them super, super simple, all the buildings around, okay? So let's just call that existing buildings is going to be that material. I'm going to leave it as gray because that will work great in terms of being able to see those buildings inside of Revit. Okay, so I'm going to do one more because let's do one of the ones with the pitched roof. It seems like a good idea. And then that's where, after that, we'll push this over to Twin. So I'm going to go back to Site. And let's do, which building is this? Is it Burnham? Okay. I'm no good with the building names. I should be. I've lived here forever. Okay, so let's go over to, I should have, Google Earth. Again, you're my friend, Google Earth. I should have known. Yeah, thanks. At least you're honest about it. So let's go where 1375 is the peak. I want to look at the edge, and then we'll build the peak last. Okay, so essentially we're going to stack it up, the box, and then put the roof on top of the box. So 1363 to 1319. Again, somebody do the math for me here. 1363 would be, I think, a safe number. 1363 minus 1319. Calculators. 44. All right. I'm totally trusting you because I don't do the maths in my head. 44 feet. So let's start with that. And I think that's pretty much consistent all the way around the perimeter, if I recall. Yeah, that's pretty consistent all the way around the perimeter. So we're going to make basically this first piece a 44-foot tall box. Okay, so extrusion. Pick lines. Oh, dear. I won't pick lines, I guess. Oh, and let's do talk while I'm tracing this out. The method that I use to get the drawing to scale, just zooming out really quick, on Google Earth, or it could have been Google Maps, either one works. I took a dimension from the edge of this street to the edge of this street. I've forgotten what that was. It was several thousand feet. And then use that to scale the map. okay, to get things roughly correct. And then I've been working from there. So same technique that we've used before on any number of projects. Okay, so that's going to start at 0. It's going to end at 44 feet. And that gets me the box. I'll go ahead and set that box as material to existing buildings. And now we need to build the roofs for it. And, you know, I could definitely use the massing model tools for it. Yeah, probably let's do that. I think it's probably a good exercise to go through. I was thinking about just using the roof tools, but it's probably more fun to just use the massing model. Let's go over how to model those things. Okay, so again, what I'm going to do is let's look at, and again, I can assume that those ridges are all at the same height. They're not quite, but it's really, really close, y'all. So let's look at the height here, which is 1376 versus the height at the edge. So that's 1376 minus 1363. So what's our 76 minus 63? 13. Perfect. Thank y'all for accepting my inability to do math in my head. Okay, so what I'm going to do, I'm going to build those in elevation and extrude them back, right? So it's easier to draw the triangle in elevation on something like this for a massing model than it is to try and bring points together or something wacky. So to do that, I'm going to go create extrusion, and I'm going to set my work plane by doing pick a plane and selecting that front edge. Okay, so I've got that front edge. Let's turn on show. That front edge is now my work plane. Okay, so I know that at the center point of this line, right? So I'm finding the center point or the midpoint of that piece needs to be a line that goes up 13 feet. Okay, so I'm going to go center point or midpoint, and I'm going to start a line that goes up 13 feet. From there, super easy to complete the triangle. So I'm just sketching it right along the edge of the roof. And again, if I am not in massing model mode, right, this would not be an acceptable level of detail for a roof. Okay, I would need to have more detail. You know, gutters, eaves, all that stuff are super relevant. But at this level of detail, in terms of context and massing, this method is perfectly adequate. Okay, so I've got that roof done. I need to do the exact same thing right here for this piece. So I'm going to go create, extrusion, set my reference plane by picking a plane, picking that edge. A line from the midpoint up. It's going up 13 feet. Oh dear. Then I'm completing the triangle. That one's a little tricky to snap too. Because that is so close to, I don't know, it's so close to either an angle that Revit thinks we should be using or something, but that's a little bit tricky to snap to. If you are having trouble with that, like I was, you can always go to a more of an elevation view, and it should be a little bit easier to snap those edges around. Green checkbox that. And again, I'm using the grips to snap to the end, this grip to snap to the end. And now I just need to do the same thing for the roof that goes across the middle. But again, it's a little bit trickier because of where the roof lands. Mainly, I'm going to need to draw the triangle. I need to create a guide to make sure the ridge ends up in the middle on that one. So I'm going to go create last piece, extrusion. I need to pick an edge of the building as my reference plane now. So I've got that one as my reference plane. And to do this one, I need to do a line that's going to come across to be honest, I'm not even sure how I'm going to do that one. You mean like using the roof tool on the slope? I could, but the problem with doing that is I do have extra stuff as the roof, and I want to be able to neaten this up last step rather than using the roof tool. I'm going to actually join those things together so it all shows up as the same element. So let's change this method just a little bit here. I'm going to cancel out of that one. And what I'm going to do is I need to build a sacrificial box for myself on this case. So what I'm going to do is I'm going to go to create extrusion, and I'm going to set my reference plane as the top of the building right here. Click. And I'm just going to build, like I said, a little sacrificial box. And that sacrificial box is going to be 13 feet tall. Okay, so I'm essentially doing that. I was hoping that I could find a nifty way to grab those edges, but it just didn't exist. So now that I've got that, I can use this edge as my reference plane for my roof piece. So I'm going to go create, extrusion, set that edge right there as my roof. And now again, I can draw the triangle for that roof really easily using that sort of sacrificial box. Poor box. Green checky box. This one is going to go from ridge to ridge, like that. Cool. Each one of these then needs to get the correct material. So they are not greens, they are existing buildings. And then the last step, and I don't know, maybe this is me being too anal retentive on things, but if I happen to show this in Revit, I really don't want that line, and I really do want this line. So the last thing I'm going to do is something like this, is select it, and I'm going to join all these together. So in Revit, there's a tool called Join Geometry. I'm going to click that roof to that roof, and you can see I now have that seam down the valley of those two pieces, whereas this one I haven't joined that together yet. I can see it there. Let's change this to hidden line so you can actually see a little better what I'm talking about. See the difference here and here? Right, so those need to be joined. So join this piece to this piece, and then join this piece to the roofs. So those are all acting now like singular elements, which makes me happier. Cool, so this is, and again, even if I'm working on all of this and I'm getting all of this stuff put together, it's definitely time to get something like this pushed into Twinmotion and starting to see exactly how it's all going to start working out. So let's go ahead and get Twinmotion launched. And we'll forward that out as an FBX file. Now, as you're building this collectively, obviously we're not doing a ton of detail on this, but the smart way to do this as a class, when you're working on a project that all of you have, is you divide up the buildings in particular. And as people are finishing buildings, you're deleting everything but the building you worked on, saving that building as Bay Hall or Burnham or whatever, and then copying and pasting those in. You always want to start with a common site plan so that you're doing edit copy, edit paste in place in Revit to build your master scene. If you don't do that, if you don't have a common thing, then each time you edit paste, you're going to have to move things around and get them accurate. But you can, as a class, all of you could sit down in Revit and bang out one of these models once you have the base in place, right? Once you have the base in place, easily within a studio time, right? So it should be something that you should begin to get really quick at getting these things put together. If you've got a lot of topography, it changes everything. What I just said, you throw it out the window. Okay, so this file now, we're going to take this and do File, Export, FBX. So, Site, Flag Plaza. That's actually a pretty good name for this file. Site, Flag Plaza. And save. So then inside of Twinmotion, import, open. I believe I sent that to my desktop. Site, Flag Plaza, FBX, open, and import. And so let's do some of the basics here. Materials. Let's start with the ground plane. Ground, nature, probably grassy grass 5. And let's zoom in. And get the scale working a little bit better with it. Ground, man-made, concrete. You know, they don't really have in here that I've found anyway, like a really good sidewalk that has scoring every so often. So I don't know, maybe I'll put this concrete road texture on there and that might be what we can work through. There's a few different types of concrete. But that starts to get the right kind of texture, I suppose. And then if you recall, the asphalt, the plan is that this asphalt right here does become something nicer for Drury Lane, something a little more pedestrian friendly to walk on. Then... you know, rubbery tarmac, because that's not the best, especially if you're here in August. Not so much fun. So that would be something that you might want to change if what you're designing interfaces with that edge. Cool? Go with me. Buildings. Typically, when I work through something like existing buildings, coplanar geometry right there. That's no good. And floating geometry. That's not so good either. Oh, no, that's coplanar also. Yeah, we want to fix that in Revit. Because in particular, you guys, when you are working through a presentation live or when I'm working on a video, that's all anybody's ever going to see is the maddening flickering. And when that happens on your ground plane, it is much worse than just that. It is, it's going to give somebody a seizure, right? So you do have to take the time to go back and fix that stuff in Revit, okay? If you're ever in an emergency and you don't have time to go back and fix it, I'll tell you the really simple fix. If I use that same concrete right here, it's almost gone. But the buildings aren't made out of concrete. So I would want to change the concrete here, like both of those, to a common color. It's still there. You can still kind of see it, but it's not nearly as bad. Okay, so let's undo that. So let's go in, and I'm going to do, there's one in here that I often go to for buildings, and I believe it is simply under wall coverings. And I usually just use a standard paint, one that does not have any texture on it, which is just plasterboards. So I'll take the plasterboards. Oh, that's terrible. No, that has one on it also. Matte painted wall. I hope that's it. Yeah, there it is. And then I'll just change the color of that, again, to something that's sort of a warm-ish gray. Like that, because we want those to be in the background. Cool? But now what we need to do is fix the terrible coplanar geometry. So to do that in Revit, let's just zoom in here. And my guess is that I have this modeled. The sidewalks are probably ending at 6 inches above grade. Yep, they're ending at 6 inches above grade. So I need to start these buildings also 6 inches above grade. So that one, let's just have it start at 0.6. Jenga again. Oh, edit in place. So I'm just going to edit those values. I guess I could be doing those. That should be 10.6 now. Math. That should be 26. I did not set that up exactly like I thought I did for y'all. Sorry. 22.6. Usually what I try and do is wherever my buildings are sitting, I set that up as 0. And mess that up. Sorry, I messed it up for all of you. Yeah, good, bad example, Dave. That one. That one. That one. And this one. 26.6. 0.6. Maybe I should be moving everything down instead. That probably would have made more sense. I'll do that before the next class. Between classes, I'm going to move the site down. And by the way, the next class will be modeling the next 2 buildings and then saving this back to DU Storage 1, so you'll have 2 more buildings modeled. Just saying. If you want to go in and model all of them, great. But 4 buildings is better than 2, right? So I'm going to do the same trick with this guy. Edit in place. I only need to worry about that base. So 0.6, finish model. That should take care of all of that geometry. And at this point, all I need to do is go File, Save, File, Export, FBX, Site, Flag Plaza, yes, Twinmotion, Imports, update my Flag Plaza, blammo. No more terrifying, flickering coplanar geometry. Okay, so yeah, in terms of your final, you guys, I'm absolutely going to be looking for stuff like that. It is almost just a given that at some point, somewhere, you're going to have something minor like that happens. If I can't pick up on it, who cares? No worries. If it's the entire ground plane flickering like crazy, which this would have been pretty bad if I drove down Drury Lane, that's all. I mean, your eye, it's instinct, right? Your eye goes to the moving objects. So you really need to watch for those kind of things, okay? Last pieces that I would start doing, and this is where it becomes a little bit relevant on your computer, is I am absolutely, like, I might not do it everywhere, right? But if I'm going to work in this zone for the Flag Plaza, then I am absolutely going to come in and start doing vegetation paints. grass and wildflowers. And, you know, we're pretty refined around here, usually, sort of. Like, usually I like using sort of the wild grasses, stuff like that. But that's really not what we do. We're going to be more like this long grass, probably. I need to set the paint diameter quite a bit smaller for something like this. And I'm going to come in and start figuring that out. And this is set up in terms of how this is working, so that once grass is in place along those edges, that it looks about right as sidewalks go. Okay, you do need to watch a little bit for something like that, where it's growing through the sidewalk. And what that means, you know, there are going to be times where it's a little bit too far away, it's a little bit too close. If I go back to painting, I can get, oh, that was an erase. You know, I can get those things in pretty well. It's all relevant to how and where the camera gets very close to your objects, right? So if I have to erase all of that, and I know that I'm going to be placing a camera right here, and I don't want that big hole in the landscaping, what you start to do is you start coming back with this long grass right here, and I can start dragging and dropping and placing these things with much more precision. More at the pace of a single file at a time. Because what you're painting when it comes in, no matter how small you get that paintbrush, I'm still painting that grouping of geometry. So when I need something to really fit and be precise, really your only method is to do it by hand and get them in more exactly where you want it. So it starts to play out like that. And then we're avoiding grass growing through your sidewalks. Cool, you guys with me? So that's how this is going to start building up. By class on Wednesday, you need to have Twinmotion up and running with something like this, a little bit more completed out. It needs to start coming together. You need to have a design idea, so you can start massing out your design, where it's going to go by Wednesday, okay? Because Wednesday we're going to jump into the animation tools. It would be helpful to have something in there in terms of what your design is doing, something blocked out. If you don't, you still need to follow through, but it will be helpful because seeing these things in motion, seeing it as an animation, is incredibly helpful. It gives you an idea of what it is that you're trying to do in terms of putting the architecture into motion. Cool? Wednesday, y'all. See ya.